Your objective today. Today I can translate verbal and algebraic sentences and solve for a missing value in a two-step equation by earning at least a 7 out of 10 on my exit ticket. Let's go ahead and take a look at that first part of our objective with the translating. Example 1. Translate the algebraic expression into a verbal expression. So we know that this is an algebraic sentence because we have numbers and we want to turn this into words. The really nice thing here is that as you read this, you want to write exactly what you read. So most of us say 3m, but I like to be more specific and go, hey, what's happening between the number 3 and our variable m? Well, it means times. That's multiplication. So I want to make sure that we're saying times. So 3 times a number m. We don't know what that number is, so we just say m. Easiest one for addition is plus 7 equals, and we're going to write out negative 14. I want to talk about this for just a quick second. So there is really never one right way to write this out. If you want to get fancy, some kids might say the product of 3 and a number m, because product also means times. You could say 7 more than a number, because more than means addition. You could also say is, because is means equals. So there are a few different ways that we could write this out, but sometimes the easiest way to write this out is exactly to write what you read. Let's take a look at another example. Translate the algebraic expression into a verbal expression. Now I'm going to kind of switch this up for just 1 second because I really want us to talk about some really quick vocabulary here. Now, I just said in example 1 that you should write exactly what you read. So if I were reading this, I would read 1/2 of x minus 9 is less than 20. But I want to throw in some real tricky vocabulary in here. So I'm actually going to say 9 less than 1/2 of a number x is less than 20. Now as you're looking at this, you're going, well, she has 2 less thans. There's a big difference between both of them. When we want to represent an inequality, we always want to put the word is in front of it. So if this case we have less than, so I would say is less than or greater to, or equal to, is greater than or equal to. So when you have an inequality, you want to always make sure you put the word is in front. Versus, if you take a look at the first one, this just says 9 less than. Now, what's sneaky about this is you're like, well, the 9 doesn't come first, the 9 came after our subtraction sign. And the 1/2 of a number came before. This is what you have to be very careful with the word the less than. If you have a number that comes before or well, whichever comes before or after, you actually, when you see the word less than, you have to flip them. So 1/2 of a number comes first. Well, that actually, if you use the word less than, has to go behind. And if you have, in this example, we have 9 behind, then subtraction sign, you actually have to pop it out front, because if you read it, you say that you're taking 9 less than another number, which in that case, we're subtracting that from something else. So be very careful with the word less than. That is pretty sneaky. And then is less than, just remember that that's going to represent your inequality. For example 3, now we want to translate the verbal expression into an algebraic expression. So let's go ahead and take a look at some vocabulary. The difference of 2 times a number x and 5 is 4. So if we take a look at this, we have the word difference, and difference means subtraction. And the sneaky thing with, if it says the difference of, the sum of, the product of, the quotient of, whatever comes after of is going to be inside a set of parentheses. Alright, so let's kind of take a look at those parentheses and see, well, what else could we do there? You know that times represents multiplication. And then when we write that out, we have the difference of 2 times, so that's 2 times a number x and 5. So here it's sneaky because it says the word and, but it also says the difference at the beginning of that. So you know you're going to put subtraction, and then you put your 5, and we said earlier that when you have the word is represents equals, so we're going to toss the equal sign and say that that equals 4. I want you to go ahead and try example 4 on your own. All right, let's take a look at what you did. This one's a little sneaky, but let's go ahead and take a look at it. We have the word less than, and we said earlier less than means subtraction. We have is, which means equals, well, actually says is equal, so that's even easier. And it's equal to 12 times a number p. Now, if you remember back earlier, we had said that when you had less than, whatever was written in front had to go in the back, and whatever was in the back had to be tossed up front. So when we go and write this, or we take a look at the answer you selected, you should have said p minus 7 is equal to 12 times p. Now we're going to kind of jump right into solving two-step equations. And when we take a look at a two-step equation, it looks something like the example I have here, 4x minus 1 equals 7. I have a couple steps down here, and even though this is a two-step equation, I have 4 steps here, and I'm going to go in depth with these when we start really taking a look at the example. So step 1, it just says to box the variable with the coefficient and to circle the integer. Step 2 says we want to cancel the circle out by using the additive inverse property. Remember, additive inverse property states that if you take a number and its opposite and add it together, it equals 0. So canceling, we want to zero those out. Step 3, we're going to bring the box down and we're going to simplify the rest. In step 4, the inverse of multiplication or division, which I like to say is everybody's favorite step. So let's take a look at a couple of examples. Example 1, 4c plus 7 equals 19. So I like to draw my line down the middle, and this is where I said we need to box and circle. You're going to box the letter and circle the coefficient, because now we have to know, okay, well, what's that first step? Well, we got it, well, besides boxing and circling, we got to get rid of that circle. And we have to do that by taking its opposite. So if you have a positive 7, the opposite of a positive 7 is a negative 7. And you guys have learned that if you do one thing to one side, you have to do it to the other. So you go ahead, bring your box down. Notice that the word bring and box both start with C. Now we have the circle, and now we know that that cancels out. Circle and cancel both start with C. Or you can take a look at the red circle and say, well, that makes the number 0, so we know that that equals 0. And simplify the rest. 19 minus 7 gives you 12. And I always say that this is everybody's favorite step, and you're going to go ahead and divide 4 on both sides. And when you do 12 divided by 4, you get that C is going to equal 3. And if you don't feel comfortable with your answer, go ahead and pop 3 in for C and do a quick order of operations to check to see if you're correct. Let's take a look at example 2. Negative 5 equals 11 plus 2x. So it's okay that our variable is on the other side. We're still going to go ahead and we're still going to box and circle. So we could also say that that circle makes an O. We could also go, oh, well, we got to take the opposite. Because that's a positive 11, you need to subtract it. So negative 5 minus 11 gives you negative 16. We know that the circles cancel out and you bring your box down. Everybody's favorite step is to either multiply or divide. And when you multiply, well, we divide here. When you divide this, you get that negative 8 equals x. And be super careful about your negatives. A negative divided by a positive is negative. Go ahead and try example 3 on your own. All right, let's see what you got. Draw my line down the middle. And we have to box our letter and circle our integer. All right, we know we have to get rid of the circle by taking its opposite. So because it's a negative 1, I'm going to add 1 to both sides. I'm going to bring my box down, so that's negative 3x. Cancels out by the additive inverse property. 20 plus 1 is 1. Everybody's favorite step here is to divide. So you should have selected that x equals negative 7. Go ahead, try 4 on your own. All right, let's see. Line down the middle, and it's okay that our variable is on the opposite side. Go ahead, box and circle. I need to get rid of the circle first, so I'm going to go ahead and do the opposite of that. That's the additive inverse property, because we know that if we take a number and its opposite, it equals 0. Let's simplify. 16 plus 12 is 28. Bring the box down. That's negative 4x, and we know that cancels out. Everybody's favorite step here. 28 divided by negative 4 is negative 7. Go ahead. You got 5. Try it. All right. Line down the middle. Ooh, this one's a little sneaky. We still box our variable, circle our integer. You guys are pros at this. You know what's inside the circle. We have to take the opposite. So a negative 14, the opposite is a positive. Bring the box down. Negative x cancels out 28. What's sneaky about this is that letter x does have a coefficient to it. It's the negative, and we know that there's that imaginary 1 there. So we actually want to make sure that we divide both sides by negative 1. And when you divide by negative 1, you get that x equals negative 28. All right, let's take a look at something a little different. I'm going to have you try one on your own. I'm still going to draw my line down the middle, and I'm still going to box and circle like we were doing earlier. And you guys know, okay, we have to get rid of the circle first by taking the opposite of that positive. Again, circle makes an opposite. Or it makes it O for the word opposite. Bring down what's inside your box. Negative m divided by 2. That cancels out, and 9 minus 14 gives me negative 5. Now I'm noticing here that I actually have division, so I need to go and multiply. And I like to multiply by the reciprocal of that, or I just like to say, well, let's just times both sides by the denominator. And notice that I did bring that negative 2, or the negative down with the denominator. It makes it so much easier. And when you multiply that, those cancel out. It's your multiplicative inverse property. All right, and we're left with m equals, and a negative times a negative is a positive. 5 times 2 is 10. Go ahead and try example 7. All right, let's see what you guys got. Y'all are pros at this now. You'll be perfectly fine. Box that. Circle the negative 11. We have to get rid of the negative 11 by taking the opposite, so we're going to add 11 to both sides. Bring down z divided by 6. It's 11. That's actually 1 divided by 6, so if we take the inverse of that, the reciprocal, we're going to multiply both sides by 6. Well, that cancels out, and z equals 66.